All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we have this time member AD is completely rigid. It's not going to bend as we apply loads on here. Cable AB is made of A36 steel. We know if we look this up, A36 steel has a Young's modulus of 29 times 10 to the third KSI and a yield stress of 36 KSI. And then our diameter here is half an inch. We also have cable CD. It's made of red brass, C83400. It has a Young's modulus of 14.6 times 10 to the third KSI and a yield stress of 11.4 KSI. And our diameter over here is 1 inch. We're trying to determine what's that maximum force we could put on here without exceeding the yield stress of either one of these members. And then also we'll figure out what's the maximum or what's the strains in each member at that point. So let's draw out one quick thing in here. Anytime we're dealing with a problem like this, one of the things I found is really useful to do is to write this quick relationship. Delta. If I have delta, I could get to my strain. Or if I have strain, I get to delta. From strain, I can go back and forth with my stress. From stress, I can go back and forth with whatever force is being applied in on anything. This is useful for me to kind of help me envision where am I going with any problem as I tackle this. So I have on this one, I'm starting out, I'm given yield stresses. So I'm kind of starting right here. Then I'm going to have to work towards force and strain. So let's document that. Start here. Start here. Then we'll work to F and my strain as I come in and do that. That's my game plan for where I'm going in here. So let's start that out. And I'm going to say the very first thing I want to do is figure out what's that maximum tension in each member. I have my maximum stress. Let's get the force. Find my max tension. Max tension. Find max tension in each of our members, in each cable. So if I'm tackling this, I have a TAB max. This isn't necessarily what it's going to be. It's just the max before it would yield. So what's my TAB max? TAB max should be my sigma yield for AB. Well, a yield stress or a stress is force divided by area. If I'm coming in and getting to my force, I just need to multiply through by area. So my force is stress times the area. So times the area of AB. And really, I have basically this idea. I know my yield stress is 36 KSI. So let's check our units here. That would be kips divided by inches squared, my sigma y, times my area. And I know I'm given in here, what do I have? My diameter is DAB is half an inch. So I could come in and say times pi times my diameter, 0.5 squared over 4, times 0.5 squared divided by 4. Or pi times 0.25 squared. Pi r squared, pi d squared over 4, it gets us to the same point. That's going to get us to this maximum force I could get in AB before I start to yield that cable is 7.069 kips. So that's going to be one of my two potential max forces in here. But let's check the other one. My TCD max. Tension in CD max should be, well, now I work with a Y. C or sigma Y in CD times an area of CD. Or this is, my sigma yield is 11.4 kips per inch squared. I should document this was inches squared. Our square inches cancel and we're left with kips. But times pi times our diameter. My diameter here was given as 1 inch. Diameter of the brass is 1 inch. So pi times 1 inch squared over 4. And again, my inches squared cancel. I'm left with kips coming out for this. Or my maximum force I could put into that brass cable, D or CD, will be 8.95 kips. 8.95 kips. So those known, where we want to go next is to say, well, both of those aren't going to end up being true. I'm not going to put the max into both cable, or odds are I'm not going to. It'd be really unique if I did. So let's figure out what the maximum force that I could apply would actually end up being. So our second step, 2, let's find P max. I need to drop that down a tiny bit. 2, find P max. If I'm looking for that, well, I know potential forces in cables. I can make a free body diagram. So let's go there. Drawing that free body diagram out. On the right side, I have TCD. On the left side, I have TAB. And one of the two of these will be their max value. But again, not both of them in there. We'll have to make an assumption and kind of come in and check it. But 3 feet from AB, we get that force P. 3 feet, that's 4 feet from CD. So we have this free body diagram. And I can work with this. So to do this, I need to make an assumption in here. I can either assume TAB is at its max, 7.069. Then we'd solve for TCD. If it's less than 8.95, we made the right assumption, we're good to go. If it's over 8.95, well, we can't go over 8.95 or it would break. We should immediately know we guessed wrong. And we just back up and start over then. So let's take a guess at that. I'm going to come in and say, let's assume that TAB reaches max first. Reaches max first. So what's that telling us? That means that TAB, we're assuming, equals TAB max. TAB max, which is 7.069 kips. And before I find P, I want to check that and say, what's TCD actually going to be equal to if TAB is 7.069? So let's just sum moments here. We'll do moments at D. Actually, let's do moments here at P, because that way we don't have to find P first. With positive going counterclockwise, let's sum up our moments about point P. TCD is going to cause a counterclockwise rotation, so 4 TCD minus our moment from TAB, because it'd be clockwise, so minus 3, our distance, times our force. We assume TAB hit its max, so we're going to use 7.069 times 7.069. And that's it. If I'm summing moments at P, nothing else shows up in here, I can set this equal to 0. And then I can solve for TCD. TCD is going to be, if TAB is 7.069, TCD works out to be 5.301 kips. And if we compare that, we're looking to what its max value was. This is less than it. This is less than TCD max. Therefore, this is a good assumption. Good assumption. TCD can't go over its max value. If we come in and we'd assume TCD first, when we solve for TAB, it would have been over 7.069. We'd have to say that's a bad assumption. Let's start over and assume TAB hits its max. One of the two of those is going to hold true for us, not both of them. I can't say TAB is 7.069 and TCD is 8.95 because the loading isn't going to get us to both of those at the same time. But if I know that, I can then come in and just sum forces in the Y. to figure out what's my force P that got us there. So summing force in the y. I have TAB. We know that's 7.069. I have TCD, which we just found was really 5.301 minus P. Gets us to 0. Or my force P is going to be equal to 12.37 kips. That's that maximum force I can get on here. When I put that on here, remember AB, or remember TCD, is only getting to 5.3 kips. That's okay because remember AB is then hitting its very max point. I can't increase this more, even though AB could hold more, or even though CD could hold more, AB would break. So it doesn't really matter in there. This is the max I can put on with either cable, not quite breaking yet. Once I'm at that point, I can then come in and say, I got to the force, I need strains, was what I was asked to find. So let's go to strains. So my third step, 3, let's find the strain in each member. And I can tackle this one just saying, well, strain is stress divided by E. In AB then, my sigma AB, let's actually find this. Sigma AB should be my sigma Y AB, because it's the one that's hitting its max value. We found that already. If we came in and we actually did this, P over A, we would get that it is 36 KSI. But we kind of based TAB on that idea. TAB was 36 times the area, got a 7.069. We know we're at 36. That's kind of how we set up our problem in here. From there, I can get to my my strain in AB. Well, strain is, or stress is E epsilon, so strain will be stress divided by E. This is sigma AB divided by E AB. Well, this would be my stress is 36 KSI. My E is 29 times 10 to the third KSI. Technically, those cancel, but for strain, we always report it in a distance per distance. We'll use inches per inch is the common one here. Or my strain in AB is 0.00124 inches per inch. And that would be my first answer in there. We can do a similar thing here to figure out what's going on in member BC. In BC, there's a little bit more we'll have to do because I have to find my stress. Not BC, that should be CD. In CD, we're saying, well, my sigma CD. I can't just assume this is the yield stress because I'm not at that maximum force that would cause it to yield. I'm not at 8.95. I'm at 5.3. So let's find what the actual stress is right now. So this should be equal to 5.301 kips divided by my area. Pi, my diameter was 1, so my radius is 0.5 squared. Should give me that this is 6.49 kips per square inches, KSI. Once I know sigma, I can then use sigma over E, gets me my strain. So my strain in CD should be my stress, 6.49 KSI, divided by E. My E in here, what we were given was 14.6 times 10 to the third KSI over 14.6 times 10 to the third KSI. Again, our KSIs cancel, but we're still going to report that as a distance per distance, inches per inch in here. My strain in member CD ends up getting us to 0.000462 inches per inch, which is our final answer for our problem in there. Again, we can kind of start here. We got force. We then were able to come back in and get stress once we knew the actual force in each. If we wanted to, we could then go on and say we could use our strain and we could get to delta in there. I know strain is delta L over L. I can work with that to figure out what is the actual deflection since I know delta for everything. If I know my actual deflections, I can figure out how twisted did that bar get. Probably not very, but I could work towards that. We can figure all of these things out. Just again, document this. This again, on my end, this really helps me a ton. Envision, where do I need to go for everything? It's an easy thing to write out. It's an easy thing to keep continuing to see. Where am I at? What do I need to do to finish the problem? It's worth writing out. But hopefully this is a useful video for you. If it was, hit those like and subscribe buttons. Stick around, watch more videos. Let's get you an A with JJ.